Okay, really excited to be here to give this webinar today on the topic, can AI predict human behavior? So the kind of punchline is I have a lot more questions than answers related to this topic, but that's really kind of the point of today's presentation. Is that's the stage that this area of research is in right now. I think it's early to suggest a lot of solutions or products or answers to these kinds of questions, but we're at the right stage now where we have the capability and the data available to start exploring the questions in a research, statistically rigorous type way. So when I talk about human behavior, I kind of want you to think in the back of your mind what I'm really thinking about is predicting the bad stuff, like early termination of a term of service or attrition, or insider threat in particular, or suicide, the things that have the highest impact that would potentially have the most value in researching. So let's dive into the talk here. So a bit of background on myself. I started academic research at Georgia Tech, where I studied math and physics, and transitioned from there over to UC Davis, where I worked at CERN, the European Center for Nuclear Research. This is where the particle colliders are, accelerate particles and smash them together. So while I was there, I worked on one of the teams that contributed to the discovery of the Higgs boson. So this was a pop science articles back a few years ago, called the God particle. It's not a scientific term, but the Higgs boson is what my research was based on. Also in grad school, I helped co-found an experiment called crayfish without the H. Cosmic rays found in smartphones is the acronym. So this was using the sensors in smartphone cameras to detect cosmic rays, which are high energy particles that come from space. So that's a bit of my academic background, physics, experimental physics-based research, a lot of data analytics and machine learning applications, and a good dose of hardware. For the last almost 3 years, I've been at Exponent in the Statistical and Data Sciences practice at the headquarters in Menlo Park. So what is Exponent? A bit about the company. So we're a scientific and engineering consulting firm. So we have experts across a wide variety of academic disciplines, over 90 disciplines, offices around the country. I'm currently in the Menlo Park headquarters. I'm relocating to the Orange County office here in a few months. So the company is about half PhDs. The history of the company is based in the legal space, so providing expert witness support and advice to legal counsel. Now we're moving more into commercial proactive research type stuff, and I'm particularly interested in government work. So over 1,000 people, over 1,000 consultants, and growing. So these are some of the areas that we focus in, and as a data scientist, there's data everywhere here, so I spread myself around. I tend to focus a lot on utilities and consumer electronics, cybersecurity, healthcare. If you can call that focus, those are some of the areas that I work in. Like I mentioned, I live in the statistical practice and work quite closely with the computer science group as well. So that's a bit about me. I like to give an intro to just kind of define some terms and throw some jargon at you and kind of get that out of the way. So this is a big mess of jargon when we start talking about AI and applications in cybersecurity. And just like the overlap in these circles is hard to distinguish and kind of fuzzy. So it's also the case with this different terminology. So this is my attempt to kind of cast some structure on this jargon and kind of put it into a grid that we can understand a little more simply. So kind of the fundamental input here when you talk about machine learning and AI systems are the data types. That's the basic application, what you're applying an algorithm to and what you're training on. So the most, it's not a clean definition, but mostly data falls into these 4 categories. Spreadsheets, bread and butter, tabular data sets like Excel spreadsheets, time series like sensor data and time streaming stuff, images and text, free text. So you can think about the jargon, that's the machine learning analysis of these types of data. At the bottom 2 rows, moving from the classical approaches to the modern approach. This is machine learning, time series forecasting, computer vision, and natural language processing. And I like this graphic. It kind of puts some structure on this world of jargon that we're addressing right now. Another really good graphic. I like to stay on top of what's trending in this area of research, and this Gartner hype cycle is a really neat way to visualize this. So this is a new report released every year, and it's fascinating to me to go and look at the year to year and how things are added to this and removed from this and track along this curve. So the vertical axis is some qualitative sense for the expectations for what this technology is going to do for us. The horizontal axis is time, and you're color coded in categories by, this is a couple years away, this is more than 5 years, more than 10 years. So one really key thing to point out here is that we're not at artificial general intelligence, and that's kind of the biggest misconception that I see when people are new to this area and thinking about AI. And kind of the perception is that AI does something more than it actually does. Where we are now is extremely specific intelligence, instead of general intelligence. So machine learning models are trained to solve extremely specific problems, and if you deviate from that a little bit, they just don't work. They only work on the data that they're trained on. Whereas artificial general intelligence is the AI from the movies that is trying to reproduce human behavior at some level, human intelligence at some level. And that's, the graphic says more than 10 years, and you can imagine that, that's much further away. So another couple interesting points to point out here, the thing at the very top of the hype cycle, the thing that has the most inflated expectations right now is AutoML, that's automated machine learning. So I'll have a slide on this later on just to give an example to discuss what this is. Stuff that's all the way to the right, speech recognition, that's, all of our voice assistants on our connected devices. It basically works, and it's selling a lot of products, and yeah, it basically works. So I'm going to spend the next few slides just going through this. Again, it's just really interesting to me, and I think you'll find it interesting too, to share what are the trends for this field of data science and machine learning engineering and analytics and all these types of roles. So this is a survey. I'm presenting graphics from a report based on this survey from a site called Kaggle. So if you're not familiar, Kaggle is a website. It's more than it used to be. It was originally a place for companies and organizations to host competitions, to host data science competitions, where they post a data set. People like me in grad school go through and try to train a model, clean up the data, go through the processing steps, and submit our solutions. And then the top solutions, sometimes you get a prize, and the prize is, it's real money, like 100K is not unusual for the top winner to go. So, a lot of competition, kind of the top. It's just a way to kind of track what's the best model, what's the cutting edge right now, because that's what the winning solutions and it would implement. So that's what Kaggle started out as. Now it's a big online forum, and a community of data scientists coming together. There's blogs, and there's even training videos now. So anyway, they put on this survey every year. This data set is from 2018. As of preparing these slides, the 2019 wasn't released. It may be released now. These graphics are for 2018. Over 23,000 respondents from 147 countries. So it's a really good cross-section of the world in this industry. So first slide, some demographic information. There's quite a large gender imbalance in this field. That's something I think we should be talking more about and figuring out how to address. The age graphic indicates young India versus an older US. So a lot of emerging people in India working in this area. The US has a slightly better gender imbalance, but still quite a large imbalance. So what fields do data scientists come from? Mostly computer science, math, engineering. There's physics, so I circle in red. I fit into that bin. When I first saw this, I was like, wow, that's really cool. Like, I guess physicists do make really good data scientists. And then I kind of thought again, well, maybe that just means, maybe that's saying something about our career prospects, that we, there's, what else are we going to do other than go into data science? So combination of those two factors makes that bin stand out. Data types. So I really like to organize things in terms of what type of data. So I like these graphics. So this is the primary roles: consultant, data scientist, data analyst, software engineer, student, research scientist. And you can kind of track along the bars with your eyes. You can see the green bar, that's SQL. That's language for communicating with databases, is weighted more heavily toward the data analyst role. I think I fit somewhere in between consultant and data scientist, and probably focus a bit more on image data than the other categories, because that's most of the projects I have. Public data sources, this is really neat. I haven't looked into a lot of these. You may be familiar with some of these, but this is a really strong resource that is available to all of us, and growing number of public data sources that are available that you can either augment your proprietary data with a public data source, or do research studies just simply on the public data. And just knowing what's out there is really useful. I'm going to speed up a bit. So tools, Python is the primary language of choice, and there are a host of other machine learning and visualization libraries that are used. Media, this is really interesting. This is, if you want to stay on top of this field, where do data scientists go to get their information, to get new, news on new techniques and that sort of thing. So I would check out some of these resources and online learning platforms. Also, if you're interested in learning this. So that's just a brief intro and overview on some of the jargon and some of the different types of data that I look at, and what's kind of the state of the industry right now. So now I'm going to move on into the main part of the presentation, which is going through some case studies to discuss what AI is doing in predicting different, common use cases in the commercial world. And I kind of want you to think in the back of your mind, what's the underlying questions here, and I'll point those out as we go along, because the idea for this talk is to take this nebulous question: can AI predict human behavior? In particular, can it predict the bad human behavior? It's such an imprecise and broad question that, by the end, once we go through these examples, I'll present a new set of questions that I think are more relevant and more easy to address in a scientific kind of way. So some of the examples are silly and some of them are quite serious, so bear with me through the silly ones. So the first of several office references. So can AI predict what I want for lunch? So the point here is there's, different demographics behave differently, right? Jim Halpert famously has the same ham and cheese sandwich every day, except notably on his first day, he had a tuna sandwich where he got the nickname Big Tuna. Can you predict what Jim is going to have for lunch? Yes. How about someone who lives in, Manhattan, who has hundreds of options every day? So the classical answer is no, you don't have a chance. And certainly, if you wanted to predict what an individual was going to eat, you cannot do something like that with absolute certainty, but you can certainly take in a lot of data and optimize how you're placing ads to get more, to get a better effect from the marketing effort. So data that has not been available more than 5 or 10 years ago, so much data is fed into these marketing algorithms to point you to what, to give you a recommendation. Like DoorDash really wants me to have Chick-fil-A right now, and I'm dying to have some Chick-fil-A, and they know that, and they're really trying to squeeze me to order Chick-fil-A, and I'm going to cave eventually. Can AI predict what I want to buy online? So this is my Amazon order history. Not order history, this is the buy again list. So I'm going to pause for 20 seconds and just pretend like you're an algorithm and look through this list, and what can you infer about me just based on this grid of orders? So it doesn't take a lot of time to look through this list and say, like, well, I probably have a dog. I probably have a small dog, in fact, based on the type of product that I order. I'm going to look at what you're responding in the chat window. I like healthy snacks. I have a dog. Good. Coffee fan. And I have allergies. I like bad coffee. Fast, quick meals. Good. Yeah, so yeah, I order food online. I have a dog. I have allergies. This is really quite a bit of information. You can build up this persona on me based on this simple order history. Imagine the power you could have if you knew additional information, such as all my search history, what products I've been looking for, what I have in my cart. I order stuff for kids, so I probably have children. In fact, I've done baby registries on different sites online, so you know precisely how old my kids are. And given more information, how long, when I'm scrolling down a list of products, how long do I pause over one particular product? There's so much information going in here to predict what to offer up for me to buy next, and it's based on this persona that is built off of the combination of all of this data. So the takeaway here is, is this model really predicting what I'm going to buy, or is it just saying, the best indicator of future behavior is past behavior? If something is consumable and I buy a lot of it, I'm probably going to buy it again. So it's not really predicting. Let me come back to the window. All right. Can AI predict what ads I will click? So this is big money, big business. I'm here in the heart of Silicon Valley. Our headquarters building is surrounded by Facebook buildings. This is kind of what this world is based on, generating money from ads. So this micro-targeted advertising, this is that kind of spooky feeling that I'm sure many of you have had, that you're scrolling through your social media and you see something and you're like, wait a minute, how on earth did they know that I wanted to buy that? Like, were they listening to my conversation? How could they know that without listening? And this is kind of the next generation of marketing, is combining all of your geospatial data, all of your activity, everything that they can get to give you ads. So the example here is you're going out to meet a friend who also has a baby. You're talking about baby stuff. The site knows that the person you're in close proximity to from your geolocation data liked a certain page for a product, and so now that site is going to offer that product to you, and you're thinking, well, I only talked to this person about it. How did they know? When in fact it's combining your people you were interacting with, their history with your geolocation data. There's a bit of lag in my slide advancing. Just a second. All right, can AI predict how I will interact with someone? I'm not sure how the video is going to work. We'll give it a shot. So this is an algorithm. Given an input frame of a video, the task is to predict what the interaction will be in the following frames. Will it be a high five, handshake, hug, kiss, that sort of thing? I'll give it like 10 seconds and see if it's going to work. Maybe I can just skip ahead and show you some frames. Here we go. Prediction kiss, accurate. Prediction handshake. Hug. So this is a very like human thing. It's predicting how two people are going to interact. And nope, Michael Scott throws a wrench into the plan. So that's my second office reference. So it's notable here that the human accuracy is not 100% accurate, right? Look at Michael right now. A person would have trouble predicting what's going to happen. In this particular application, the machine accuracy is lower than the human accuracy. There's a lot of notable cases where the computer accuracy has exceeded the accuracy for humans. For example, image classification. But this very human prediction kind of application, the machine's still behind. So I'm also interested in the transportation industry and autonomous vehicles. So this is a cool example. Typically, when you think about self-driving cars and autonomous vehicles, you're thinking externally to the vehicle with different various sensors. This application points sensors and cameras internally to the vehicle to look at the driver. So for me, for example, it's just an old habit. I always look over my shoulder before I'm going to change lanes. Even if I'm not even focusing or not even looking, it's just a habit. I look over my shoulder. That would be an application for a classification algorithm to say, is my face looking forward or is my face looking backward? I'm probably going to change lanes and then combine that, fuse that data with the external sensor data to give a better overall picture for what's going to happen. Maybe there's you get an alert because someone's in your blind spot when you're anticipating to change lanes, that sort of thing. All right, I'm going to skip the video in the interest of time, but I encourage you to go. There's a Netflix documentary called AlphaGo that's really fascinating, where an AI algorithm was trained to play the game of Go and had some notable successes against really world-class players. And there's also in the links in the bottom an example for a poker playing algorithm. Two very classically intuition-based human intuition-based games. Okay, so now we're getting closer to the main point of this conversation, which is saying, can AI predict things like insider threat? So let's transition to talking about HR data. So this is a public data set that I've put together into a demo to illustrate some core principles of machine learning and some applications in kind of a relatable data set, and steering us toward, well, what kind of data do we have from DoD and other agencies that could potentially be leveraged to do this sort of thing for those agencies. So this public data set has a list of features I've organized into categories: organizational, demographic, pay-based, overtime, satisfaction metrics, and stuff like how long you've been there, how many other companies you've worked, and so on. So the goal here, you can imagine a couple goals. One, you could want to know, well, which of these features, which of these variables are the most predictive, which are most important, which are the key indicators that drive why someone would leave a company or end their service early, be discharged. And the second question you would want to know is, for the current employees who have not left, which of those are most likely to leave, and is there anything we can do about it? So to address that first question, which features are most important? So a lot of machine learning models output a feature importance, you can use to rank how predictive or how informative, how much did that feature contribute to the final output. And you can plot those up and rank them, and it sort of follows your intuition for this application, where overworked and underpaid stuff is more important and some organizational stuff is less important. So this can be used from a very high level to say, say we want to improve retention at our organization or our company, and say we have finite resources, we want to get the most bang for our buck. Where do we invest that? How do we ensure that we're retaining the most people? Other than just paying people more, which areas can we put the most attention to get a higher ROI? So you can look at this higher list and say, other than how people get paid, overtime is very important. So maybe you want to focus on redistributing the workloads and stuff like that. The other business motivation question you would ask is, given the current employees, who's most at risk, and for top performers, do you want to incentivize them in some way, or rather do you want to try to understand what those higher risk individuals have in common, and then address that for the overall organization to improve things for everyone? If you look at the last row or the last column in this table, you'll see a risk score, something else that machine learning algorithms can output. So this example, it's a binary classification. There's only two output categories. Will the person be at the company, or will the person not be at the company a given time period, say a year from now? And you have labels for that data on historical data. Given a individual's input, did they leave the company or not? You have those labels. So even though it's a binary classification, you're predicting 0 or 1 for the current individuals. You can output the weights and biases, the weights in particular of a model you can use to calculate various metrics like risk scores. So this is the slide discussing automated machine learning. So just for this demo, I took one of the models that I was playing with, and to demonstrate what an application of automated machine learning would do, you can use this either to select a model. So if you have a set of different models and you don't have an intuition about which one would be best, you can say, well, evaluate the performance on this set of models. Or you can focus on one individual model that has a set of parameters, such as those shown in this table, and you can scan over a grid of those parameters, and you can output the best performing model, which the parameters highlighted in red. So you can increase your performance score on a model by scanning over the parameters input into that model. This comes at the expense of increased computational complexity because you're training multiple models and picking the best one. And another important note about automated machine learning is, of course, you want to optimize the training stage. You also want to be careful not to go too far and overfit the model. But the main point here is this: it really only applies to this model fitting stage, not the entire. You can't, it's difficult to automate something like what's the business question motivating this analysis, or what type of data do we need, and how do we extract the key features from that? How do we produce a report? There's some research on automating feature extraction, but for traditional machine learning applications, it really helps to have a subject matter expert to tell you, to tell the model what features it wants to take. Okay, final example, will my illness reoccur? So I really like this example, predicting whether someone will have an unplanned hospital readmission within the next 30 days using only discharge summaries. So these are free text doctor's notes, basically. The state-of-the-art model has a performance score of 0.75. Using only these doctor's notes, the score is 0.7. So then the idea would be to merge these models together, to ensemble those to get even better performance. But this is a really good intro, a really good example for analyzing text data for a classification problem. And the kind of takeaway here is there's often ways to use data that may not be used in a standard analysis. You can augment your tabular data with other data sources, including text and images. Okay, so this is the wrap-up slide. So taking all these examples and kind of parsing them out to ask a set of more relevant questions, more addressable questions. I think thinking about, can AI predict insider threat? I was at an event recently, and there was a leader in one of the armed forces. I'm not sure of his rank or the which area it was, but he asked during one of these presentations, he asked, I think, the most relevant question that I've heard in this field at all, which for some background, the presentation was going through a handful of the most notable worst cases of insider threat for the U.S. government, Snowden, etc. And there were, you can pull out a set of indicating factors, sort of analogous to this HR data set, like how much someone's paid, how long they've worked at the company, the key indicators for insider threat. Experts can tell you, can rattle these off, like financial issues, unexpected travel, relationship issues, mental health, all, there's catalogs of these kind of features. So this presentation was going through a few cases, and it showed a table of 4 or 5 individuals and a set of these indicators below. And the question from this leader from the audience was, looking at those features, it's kind of unfortunate and kind of sad, but from his experience leading people in an armed force, those aren't distinguishing features necessarily. It's not atypical for someone to have had abuse in their childhood, or struggle with alcoholism or something like that. It's not, that those factors alone aren't enough to distinguish an individual such that a machine learning model could latch on to those to pull them out. So that's this blob diagram on the lower right hand slide. If you can think about taking all this data and projecting it down to 2 dimensions. The blue dots would be everyone, and the red dots would be the insiders. See, it's all mishmashed together. So what that means for a model is my intuition says any model to predict something like the worst cases of insider threat, you're going to admit a large number of false positives and false negatives, and then you have to decide, what are you going to do about it, and what's the relative cost of those, of looking at dedicating resources to investigating all of those false positives. And you prioritize recall, so you want to prioritize catching things, then you admit more false positives and have even more work to do. But kind of the root, the most fundamental question here is, can you train a model to predict Snowden? Can you train a model given an arbitrary amount of data, all the data that we have access to? Can a model be trained to predict insider threat? And the explanation here is yes, sure, you can train a model to predict whatever you want and evaluate the accuracy, but in those cases where you're trying to isolate those extremely specific cases, it's going to look like the upper graphic on the far right, where the curve is overfit. The decision boundary kind of snakes around everything to really grab those individual cases. More realistically, it's going to be something like the middle, where you're admitting a lot of false positives. So I'm a little bit over, but let me wrap up. So I think we're at a really critical stage right now where we have a lot of questions. There is research being done to address these questions, but we should be trying to really focus in on what are the machine learning, what are the statistically rigorous type things that we can ask, and what data do we have to address those questions. We need more research studies looking at this sensitive data to try to understand the application of AI in these areas. So that's me. That's my presentation. Thanks for your attention. I am a consultant. I'm looking to grow business in this area, particularly in the government space. So please don't hesitate to reach out for anything. If I can't help, I can refer you to someone who probably can along any stage of this data science life cycle. So thanks for your attention.